Hello, friends. This is Jim with Science Talk. As you can see, I'm trying to get something new, even more. Um, Trying to do things with the computer straight up, and no backdrop back there. Some of you suggested you did not want to see the backdrop. Anyway, um, news I want to share with you is about the Earth's magnetic field. This is a story I have discussed with you folks before, so this is kind of a bit of an update, a bit of more research being found, and helps us understand better what might be happening. Now, there is no doubt that the magnetic field is weakening. Okay? And there has been some concerns raised that it could flip north and south magnetic poles switching. And in the process of that happening, with the weakening of the field, the satellites would be more exposed to dangers from damage from the solar wind and the ionic particles, as well as organisms without the protection from, again, the bombardment of the particles and UV radiation and so on, increased risk for cancer. So a new study has done some examinations, and the new study suggests that the field has been in a similar state before without necessarily flipping. So in a study that's been published in the journal Proceedings of the National Academy of Sciences, researchers compared the current magnetic field, which is created by the Earth's core, the outer core being liquid and sloshing around, that creates an electromagnetic field. Okay? They found that today's patterns do not resemble the two most extreme disruptions in the past 50,000 years, when the magnetic field nearly reversed. Instead, the magnetic field appears similar to the field during two other periods, one that occurred approximately 49,000 years ago and one 46,000 years ago, when the magnetic field wobbled but did not flip-flop. So, however, just because it wobbles does not mean there may not be ramifications. If the field should the field continue to weaken, as I mentioned before, electronics could be affected, especially those that are above what's called LEO satellites, low Earth orbit. And they could be prone to damage even without a total reversal. Earth's geomagnetic field, as I mentioned, shields the planet's surface from the charged particle in space that does damage to organisms, to tissues, to electronics, and so forth. And not to mention electrical grid, the electrical grid that brings power. So, currently, magnetic north is very close to the geographic North Pole, and magnetic south is very near the geographic South Pole. That has been the case for about 780,000 years. Now, yes, especially the northern pole, the magnetic poles do wander a bit, but they're staying not too far from geographic North Pole. So they're kind of wandering around up in the polar regions in both cases. 780,000 years it's been like this. That was the last time the geomagnetic field underwent a complete reversal, with magnetics north and south swapping places, basically. Now, the field has been weakening by approximately 5% per century since direct observations started in 1840. Indirect observations hint that the weakening might have been going on for the past 2,000 years. So, Dr. Maxwell Brown, who studies paleomagnetism at the University of Iceland, and his colleagues wrote in their paper that a weak area called the South Atlantic Anomaly, which stretches from South Africa to Chile, has been pinpointed as a potential ground zero for global polarity reversal. Brown and colleagues wanted to compare today's conditions with the magnetic field of years in the past, and they focused on two what are called excursions. Now, an excursion is where there is a major disruption in the geomagnetic field, but does not necessarily induce a complete global reversal of magnetic north and south. One of these excursions is called the Shop Excursion, which occurred about 41,000 years ago. During that excursion, the magnetic field was a mess. It was just muddled and nothing well defined. So there was no clear magnetic north, no clear magnetic south. The other excursion was Mono Lake, which was about 34,000 years ago, and was indicated by very weak magnetic north and south. So the researchers looked at these geomagnetic events, and they modeled, and they found that neither looked much like the field's conditions today. During the Shop excursion, magnetic north and south weakened with increasing rapidity, and two large anomalies grew over Central America and Southeast Asia almost at the same time. Over thousands of years, and this is from their report, over thousands of years, patches where the direction of magnetism was reversed popped up, and the intensity of the magnetic field dropped very low. During the Mono Lake excursion, magnetic north and south weakened, but for a shorter period of time. There were lots of little patches of reverse magnetism appeared across the globe. There were also lots of patches of altered intensity in the field strength, which appeared erratically and vanished again. Then, over a couple thousand years, the field stopped wavering and stabilized with a strong magnetic north and south. The researchers continue. Today's field is not as weak as the field was during the Shop or Mono Lake excursions, and it has just the one intensity anomaly, the South Atlantic Anomaly, which I mentioned a few moments ago. So Professor Brown and colleagues argue that there is not enough to seed a full global reversal. That's where they're coming down on. Rather, they wrote, a major excursion or magnetic field reversal probably requires a lot of little nucleus points around the globe. Basically, you have these little areas of instability. Backing up their argument, they found two times, 49,000 years ago and 46,000 years ago, when the geomagnetic field looked a lot like today, but in both cases the field recovered without any extreme events resulting. And those 2 years, the 49 and 46,000 years ago, were the ones I mentioned at the outset of this video. So, if the researchers are right and the magnetic field does not reverse, well, there still could be problems, all what I have mentioned earlier. Already, the South Atlantic Anomaly has caused, on occasion, some electrical failures on the satellites. And they conclude with a continued decrease in field intensity, issues such as this will become more widespread. So, this is just an update I wanted to bring to you about the condition of the magnetic fields and what the situation is with the geomagnetic north and south. And as I said, if the fields weaken, we don't have that protective counterance to the solar wind, the charged particles that come our way. Weaken magnetic fields puts satellites at risk, puts electrical grids at risk, and puts living tissues at increased risk for developing cancer. Anyway, we'll talk soon. Thank you for your time. Hey folks, just a reminder to please subscribe and click the bell so you know when I drop a video. Please share my videos, please tell others of my channel and of the work that I do. I also hope that you will consider becoming a patron at patreon.com/Science Talk with Jim Massa, where from time to time I upload videos there exclusively for my patron subscribers. Details in the description box below. Thanks.